Okay, question 14. An arrow is fired at a target. The distance x meters from the center of the target that the arrow hits is a continuous random variable function with the following function. So here, between 0 and root 3, and everywhere else it's 0. So verify that it is a probability density function. So to be a probability density function, that means that you have to equal 1 between your two bounds. So we're going to verify that using technology. So we want to integrate our function between 0 and root 3. Now I'm stating this because you need to show what you put into the calculator to get full marks. So therefore we want the left-hand side to equal the right-hand side, if true. Okay, so now over here we are going to go to our integration function. I'm going to put the square root of 3 at the top. Oh, no, delete. Okay, so in there we're going to put fraction 3 over bracket 1 plus x squared bracket and 0 is our lower bound. Root 3 is our upper bound. And if this is true, it will equal 1. So yes, it does. So I'm going to write 1 is equal to 1, verified with technology. Okay, now the second one, to determine the mean distance from the center of the target. So if you look at the sheet given to you by QCAA with all the formulas, you can see that there's continuous random variables in the statistics section, and there's one for mean and variance. So we are going to steal the formula for mean, which just states that we need to multiply our original function by x and then integrate that. So now we're going to be integrating, still between 0 and root 3, 3 pi bracket 1 plus pi x, close bracket, close bracket. We're going to multiply it by x to get, oh, I've got dx up here, to get what our mean is. So over here, I'm just going to adjust my formula above. Go back through. I'm going to put a bracket around the function. Multiply it by variable x, press execute, and there we go. So our mean for this one is 0.6619. For statistics, remember we normally go to 4 places. So therefore, we'll just leave it at that. Okay, so next one we're going to do is determine the standard deviation from the center of the target. For statistics, it's important to leave this stuff up on your screen in your calculator because you want to carry your answers forward. Every time that you don't do that, you're going to get a rounding error. And then because you're dealing with such small numbers in statistics, those errors carry forward and become big problems later. Okay, so our standard deviation is just the square root of our variance. So standard deviation of random variable x is equal to the square root of our variance. So we're going to calculate variance first. Okay, so to calculate variance, if you look at the formula here, it tells you that you're going to integrate, still between 0 and root 3, x minus your answer from above. Like I said before, we're going to steal that answer. Okay, and then we are going to multiply it by your original function. Dx equals. Okay, so back up here, we're going to adjust our formula. So I'm trying to get away with not having to do the whole thing again. Oh, let's see if this works. Okay, so minus shift, enter. I actually don't think this is going to work. We're going to have to re-enter it in again. Otherwise, it's going to steal the answer from above. Okay, so entering it in again. Integration of bracket x minus shift, enter, close bracket, squared, bracket, 3 over pi, bracket, 1 plus x squared, close bracket, 0, and root 3. Okay, execute. Okay, so that gets us the answer of 0.2158. So my variance here is going to be 0.215, and the 6 will make the 8 round up to a 9. So to get the standard deviation, we're going to take the square root of our answer. Now, remember, we are not going to use the rounded answer. We are going to put it in the calculator as the square root of answer so that we don't get any rounding errors. So my next thing, square root, answer, execute. So now I work out that my actual answer for the standard deviation is 0.4646. And that's it for question 14.